Hello students, I am Dr. Saliha Jamal from Department of Geography, Aligarh Muslim University, Aligarh. So today we are going to discuss about the topic spatial analysis. In previous lecture you must have studied about the different aspects of the spatial analysis. This lecture will introduce spatial analysis, the types of spatial analysis, which is into 6 categories, and the importance of spatial analysis, why spatial analysis is important not only for mapping and physical attributes, locations, but even also how we are going to use it in day-to-day life. So, starting with its brief introduction, firstly, I would like to say if we are talking about the spatial analysis, the term spatial means we are talking about the spatial units, location, some features, the boundaries defining the Earth's surfaces. Now coming to its technical meaning, the spatial analysis, which we can say that simply involves examining, modeling the different spatial data features like location, attributes, relationships, understand their geometric and geographic properties. Further, I am going to discuss about this geometric and geographic properties. This particular spatial analysis employs various computational models, not only the computational models but different analytical techniques, algorithms, and different processes of geographic information is generally used for the spatial analysis, generally to assess the suitability for a specific system. These all tools, techniques and analytical techniques will be discussed in the further lectures one by one. This approach of spatial analysis finds application in diverse fields. It is multidisciplinary in terms like it can be used in astronomy, it can be used in healthcare, it can be used in monitoring the different types of crops, the different segments, which crop is occupying how much area. It can also map out and find out the urban ecosystem management. It can be also utilized in disaster recovery and many more which will be discussed. If we come to its core, the spatial analysis generally extracts various useful information, insights from the spatial data. If we're talking about the spatial data is particularly pertaining to the space, that is features, objects, locations, their relationships may be termed as spatial data. That these spatial data in spatial analysis is numerically represented to the physical entities within a certain geographic coordinate system. This serves as the spatial unit of map, and it includes a wide array of techniques for exploring, for investigating, for interpreting and deriving useful insights from the spatial data. In general, we can say that spatial analysis is generally analyzing, exploring and investigating various spatial phenomena in order to take insight which is useful to solve various problems on Earth, on this planet. The components of spatial analysis varies in various aspects. It is from simple to the complex. It depends mainly on what is the problem that we are choosing to solve. Then with what objectives we want to choose that we want to achieve a certain goals, what are the types of data we are going to use, characteristics of the data, and which are the analytical methods we are involving to solve that particular problem through the particular database. So the components are based on these various characteristics. To understand well what is actually the spatial analysis, as I said, the word spatial analysis, spatial is related to that. It means it should be related to some aspects of space, locations. For example, if we have to define the average income of a group of people, it means it will not qualify the spatial analysis since the result is not influenced by the location. We are just determining the average income of the group of the people. But when it comes to the spatial analysis, like for example, calculating the center of United States population, that qualifies as spatial analysis because it directly relies on the residence location. Finding out, evaluating the population of capital city of or the capital of Uttar Pradesh, that also implies the spatial analysis because it is related to the location. It means spatial analysis will always be related to the location. As for example, in previous example, we have just evaluated the average income of a group of people. We haven't defined any locations regarding that, so that will not qualify the spatial analysis. So one thing students, you have to keep in mind, the space location should always be there in spatial analysis. When we are talking about the spatial data, I have already said what are the spatial data. Simply the spatial data are different phenomena, their distributions, their location, objects, features, attribute, characteristics of those features can be termed as spatial data. They are generally categorized into geometric spatial data and geographic spatial data. If we talk about the geometric data maps spatial, then geometric data generally maps spatial information on 2D surfaces. But when it comes to the geographic data, it represents latitude and longitude overlaid on a sphere symbolizing the earth. Means geometric data just maps out on 2D surfaces, but when it comes to geographic data, they generally represent the latitude and longitude which is overlaid on the sphere. It means symbolizing the sphere means symbolizing the earth surface. For example, here you can take the example of Google Maps, which are we are using Google Maps while traveling from one place to another place to find out the routes or fastest routes and etc. So these Google Maps utilizes 2D data for navigation, whereas GPS devices, if you are using GPS devices during various functions or even in the surveys, we find that it provides detailed geographic information. Not only this, when we are talking about the geometric and geographic data, it becomes very important to talk about the important components of geospatial analysis. We are talking about here geospatial analysis, not only the spatial analysis. So there are two important components of geospatial analysis, that is georeferencing and geocoding. This I am just introducing here and that will be discussed in detail in further lectures. So georeferencing is one of the important component of geospatial analysis. In this, generally we assign data coordinates to the vector or raster to model the Earth's surface. Vector data, raster data has been already discussed in previous lecture. If you want to see, you can visit previous lecture. So georeferencing is simply assigning the coordinates to the vector, that is point, line, polygon data, or the raster data, that is the characteristics and attribute of those data in order to model the Earth's surface. But while we are talking about the geocoding, it identifies precise locations, precise addresses, such as we are talking about states. We know if I am talking about the Uttar Pradesh, it has a precise location. It cannot be said that the Uttar Pradesh is located at the place of some other state. It has its precise address. Talking about the certain countries, if we are talking about Australia, it has its precise location. Means geocoding identifies precise addresses, such as we can give example state, countries, district, block, units, anything precise. We are talking about the precise location. So these georeferencing and geocoding are the basic and the essential components of geospatial analysis. So students, when we are talking about the spatial analysis, it becomes very important to understand actually what is spatial analysis. Simply we have defined it related to the space, spatial units, location, features in which different tools, techniques, analytical techniques are being used to get the insights, information, useful information in order to solve various problems. So this is the geospatial analysis, and if we are dealing with geospatial analysis, we should be very clear. We have to deal with the spatial data, and when we are talking about the spatial data, it means we should be very much clear about the geometric and geographic data. And already we have seen that geometric data are only mapped on 2D surfaces, but when we talk about the geographic data, it means that it is represented by latitude and longitude overlaid on a sphere. Why I am saying overlaid on a sphere? Because sphere symbolizes the earth. So these aspects are very much important to get it clear for the further understanding. Spatial analysis, geometric data, geographic data, two important components of geospatial analysis, that is georeferencing and geocoding. So after discussing these basic aspects, now we have to discuss about what are the different types of spatial analysis. The different types of spatial analysis, that depends upon the even the type of method we are going to employ, the different characteristics of data, what type of data we are using. Thus it can be said that the different types of spatial analysis that varies from a simple to sophisticated one. So in this course particularly, the spatial analysis will be divided into 6 categories, like queries and reasoning, measurements, transformation, descriptive summaries, optimization, and hypothesis testing. So these are the 6 types of spatial analysis, and during the discussion we will understand that it varies from simple to sophisticated. This lecture will just introduce these 6 types of spatial analysis, and in further lectures each and every spatial analysis will be discussed in detail one by one. So coming to the first type of spatial analysis, that is queries and reasoning. As the word signifies, queries and reasoning, it means it is one of the most basic analysis operation in which GIS is used to answer simple question that is mostly posed by the users. No changes occur. It is very important to note that in queries and reasoning, no changes occurs in the database, or even no new data are produced. Just simply in queries and reasoning, the simple questions are answered, which is generally asked or posed by the users. For example, if we are talking about the locations of the metro station, we are talking about the locations of the hospitals, schools. For example, if you are talking about the government hospitals, there are 5 government hospitals if is in a certain place. So it means there are 5 locations where they are located. We cannot manipulate it to the 4 government hospital. We cannot change the data to 6 government hospital. It means in queries and reasoning, no new data is produced, or even the database is not changed. Just simply the questions which are posed by the users, that is being answered without any change. That's why it is one of the most basic analysis operation that is used. Similarly, coming to the next type of spatial analysis, that is measurements. When we talk about the measurements, as the word suggests, generally the measurements are represented in numerical values. So being the part of spatial analysis, the measurement here is geographic data. Simply it can entail numerical values that describes various aspects, just like length, area, perimeter, shape. Not only this, but the relationship between the objects, like if we are taking the 2 points, the distance between the objects. If we have to find the direction of one object from the other object, means mainly the spatial data entails simple numerical values to describe these aspects, whether it may be length, whether it may be perimeter, whether it may be shape, slope, aspect, or various types of relationships like distance and direction. So this is also because I have already said, when we go one by one, the different types of spatial analysis, that also varies from simple to the complex one. So when we see in a scale, these two, the queries and reasoning and the measurements, are the very simple one as compared to the other one. Now coming one of the most important component, one important type of spatial analysis is transformation. As the word transformation suggests, transformation, some changes are going place, some changes are going. So the transformation are also basic spatial analysis method that modify the data sets. Means in previous two, no modification of data sets or no new data sets are produced, but in transformation type, modification of data sets are available. For example, these modification can be done through combining different data sets or through the comparing one data set from another one, thus combining or comparing in order to derive new data sets, new insights, new information from the spatial data which is available. You can take the example, students, like land use, land cover. If we are talking about the present land use, land cover and the changes over different time period, for example, if we are taking decadal time period of 30 years, if we are taking, so we have to take the data of decadal data, spatial data of land use, land cover of 30 years. Decadal data. So by combining that data, we can see the present land use, land cover change, and not only this, we can also assess, we can also have the new transformation data, that which land cover has changed to different land uses from past to present. So thus new data set can be created. Not only this present, but even we can simulate, we can find out, we can predict the future land use, land cover transformation through the spatial analysis, thus creating again new data sets for and getting the important insights for which can be used in further policy making, decision making, etc. So this is one of the best example you can give in transformation. So in transformation, it is important to know, students, here we can modify the data sets. Here we can produce new data sets by combining different data sets, by comparing different data sets. These operations of transformation mainly rely on geometric, arithmetic, logical rules, and can involve converting raster data to vector data and vector data to raster data. This transformation also includes tasks like creating fields from the objects collection or identify object collectors within the fields. So thus transformation is one of the very important type of spatial analysis where certain operations are run to form the new data sets, or even we can also modify the different spatial data. Now the fourth one is descriptive summaries. Again, descriptive summaries. Normally we use summaries, the term summaries in terms we are getting essence of something which is very much descriptive in nature. So we have to find out the essence of that description in few points or few lines, that is defined as summaries. Similarly, in spatial analysis also, when we are talking about descriptive summaries, in this spatial analysis, we know we are dealing with the spatial data, a large amount of spatial data, voluminous amount of spatial data. So descriptive summaries of spatial analysis, what it generally aims to capture the essence of the whole data sets to which we are dealing with. What is the essence of that data sets? And that can be represented with one or two numerical value. For example, if you are having the descriptive statistic, spatial data, voluminous data, some sort of numerical values which is spatial equivalent of common descriptive statistics that can be used to find out the essence of that particular spatial data. For example, like mean, taking out the mean of that particular data means you can present the essence in some single value, or even we can present in mean or even in standard deviation or various different types of different correlation statistical analysis can be also used to describe the essence of a whole in few values. So descriptive summaries, in short we can say, it simply aim to capture the essence of the data sets through one or two numerical values. Now coming to the optimization techniques. After the descriptive summaries, optimization techniques are also very much important, very much important type of spatial analysis. Here in optimization techniques, these are perspective methods, we can say, that which is designed to determine the optimal object locations based on defined criteria. Means we are finding out the optimal location. This is mainly used, we can say, in market research, or even for the, we can say, package delivery operations, various other fields. For example, through the optimization techniques, if a certain area, urban area is prone to urban flooding, through the optimization techniques, we can find out the optimum location or suitable location for introducing artificial water body in order to increase the water holding capacity of that particular urban area. So during the surface runoff, the holding capacity of water capacity of that area should be increased, thus solving the problem. Another example we can say, if a certain urban area is lacking in green space suppose, so we can find out the optimum proper location, certain sites where the green spaces can be introduced for the making the city more resilient, sustainable and livable. Not only this, optimum location for the hospitals, for the different educational institutes can be find out, which can serve the population in more efficient and better way. So optimization techniques are now very important. They help to identify the most efficient solution to the various problems. And in day-to-day life, we need certain, because we are going for the finding out the certain metro stations, or which are the nearby hospitals, nearby schools, or different shopping complex. These optimization techniques can help in location of these facilities in amenities which can serve the population in better and more efficient way. So this is also one of the very important type of spatial analysis. Lastly is hypothesis testing. In spatial analysis, hypothesis testing. When we talk about hypothesis, simply it is an idea which explains something and which is not tested whether it is correct or not. So it is just an hypothesis is just an idea which explains, just an idea having explanation of something, but still not tested whether it is correct or not. So this is also, hypothesis testing is another type of spatial analysis which involves reasoning of the sample results to draw conclusions about the entire population. We are going to draw the result, the conclusion of a whole population from the sample. It not only allows to draw the conclusion from the sample for the whole population, but it also allows to assess whether an observed pattern, certain type of pattern, trend could occur by chance based on sample information. That, and while hypothesis testing, the fundamental to inferential statistics and statistical analysis Applying hypothesis testing to spatial data can pose again great challenges, but all these challenges can be solved through the various different types of spatial analysis technique. So on one hand, the hypothesis testing to the spatial data can pose challenge, but on the other hand, the various tools and techniques of spatial analysis can solve this problem also. So these are the major 6 types of spatial analysis that we have discussed. Once again, the queries and reasoning, the measurements, the transformation, and descriptive summary is the fourth one. Fifth one is optimization techniques, and the sixth one is hypothesis testing. And all these types of spatial analysis is important in one way or the another way. And as I said, as we move from one type to another type, we can see that it varies from simple to complex, but all these types of spatial analysis helps to solve day-to-day problems, helps to narrow down the voluminous data and to get the useful insights from the spatial data. Now, after understanding what is spatial analysis, students, and what are its different types of spatial analysis, why we are studying this? First, so it becomes very important to know about the significance of spatial analysis, that why it is so much important. So spatial analysis is more than mapping physical objects, because many times it is a misconception. Spatial analysis means we generally deal with the mapping of the physical objects. So this is a wrong notion. Is actually the spatial analysis is more than the mapping of the physical object. As we know, the spatial information is collected from multiple sources, from the satellite imageries. Even in the satellite imageries, we can get the information, information at very fine resolution, previously from 30 meters, then 15 meters, then even 1 meters. Very fine information can be received. Spatial information can also be received through the aerial photography, whether the photography taken from the hot air balloons, aircraft, drones, etc., or even from the different surveys using GPS, etc. So as we know, the spatial information is collected from the multiple sources. So the decision makers can integrate these varied spatial data which is collected from the different sources, and can use in consolidated version of this spatial data to take action based on the need, what is needed. So action can be taken by using and integrating these data which is obtained from the different sources according to the need. For example, spatial analysis can aid in traffic management in an urban setting by knowing the traffic flow, the hour in which the traffic flow is higher, what is the alternative route that can be found out, what ways are the possible ways to minimize if there is certain jam or congestion in particular urban setting. So spatial analysis can aid traffic management in urban setting. Not only this, but we can even make the cities more resilient, sustainable, and livable through various urban ecosystem management. As I have said previously, we can monitor blue-green infrastructure for making the places more sustainable and more resilient. We can monitor even the microclimate of different places, the causes behind the spatial causes behind the microclimatic changes, and we can give certain recommendations also accordingly. So we can in short we can say that these type of functions that allows authorities to take steps towards building a resilient places, resilient urban spaces, etc. The technology can also allow users to check on geographic progression of the diseases in healthcare field. We can also use this spatial analysis. Here, the geographic progression of diseases, the origin of the diseases, the spread of the diseases, the diffusion of the diseases, the hotspots of the diseases, everything can be find out through this spatial analysis, thereby invest in efforts to control its spreads, and we can contain if certain epidemics or pandemics is seen. Moreover, the governmental bodies can also use this spatial data to map vaccination strategies for a geographical area during a deadly pandemic. The best example we have seen recently during the COVID-19, where the government has used the spatial data to contain COVID-19. It has also used the spatial data for vaccination regime, etc. So, today in this modern world, when we see that the spatial analysis is becoming day by day an essential part of our everyday routine. For example, from booking a cab on an app, or even for booking a meal on an app, tracking our e-commerce or tracking our food deliveries, tracking the running status of any train we can finding out the fastest routes while traveling from one place to another places, through accessing GPS and all. So through this we can see that spatial analysis is becoming one of the most important part of our routine life in day-to-day life. Although the spatial data such as satellite pictures have been existing from long, but this data, if we see the data, either we can see the census data, either we can see the satellite data, the aerial photographs data, these data is in vast volume, very big data. Filtering through this vast volume to generate usable information is quite a task. If only this vast volume data can be filtered according to the particular need, some usable information, if some usable information can be generated, then only this vast volume data is useful. And here come the task, the role of the spatial analysis, which filters the data according to the vast data, the data which are in use, that is generally selected, which is not to be used for the particular purpose, that is generally omitted, and we can say a useful insight is gained by running certain operations of the spatial analysis to get the useful information. So however, now what we are talking about, we are also talking about the artificial intelligence, AI and machine learning. This is coming to fore. Spatial analysis has become significantly accessible, boosting profits for the business and many times saving lives at times. For example, there are certain indicators also through the spatial data. If someone is in some dangerous position, that can give alarm. There are certain settings, apps that can give alarm to the particular person and can give information that particular person is in some trouble or in some danger. So thus many times it also not boost profit for the business at all, but also save lives at time. So nowadays the spatial analysis is playing a very big role in making our life more easy, as if we compare it from the past. Now sitting at our home, we can order the meal, we can track their deliveries. Sitting at our home, we can order various medicine. If someone is alone and not feeling well and cannot go outside, similarly they can order their medicine. So you can see, we can see the running status of different transport through different apps. Everything we can book, each and everything. So everything is possible now if we compare. Day by day, the spatial analysis is making our life more easy and easier. Thus, it can be said that spatial analysis is very important as a subject that is to be studied and its application to be known. So that's all for students for this lecture. In further lecture, also in next lecture, we will be dealing with the different components of the spatial analysis and the processes of the spatial analysis. So have a good day. Thank you.